Welcome to The Explainer. Today, we're jumping straight into what is, honestly, a cinematic, incredibly high-stakes story of engineering survival. It's us against the ultimate villain of our solar system. We so often look to Mars as our next frontier, right? But right next door is a world that has pushed human ingenuity to its absolute literal breaking point. We are talking about Venus, Earth's twisted, toxic sister. And we're going to unpack the incredible, almost unbelievable attempts to actually land a functional spacecraft on its surface. Okay, so let's set the scene here. Imagine an environment boasting a blistering surface temperature of 465 degrees Celsius. To put that into perspective, that is not just hotter than your kitchen oven cranked all the way up. It's hot enough to instantly melt a solid block of lead right into a puddle. And if that isn't terrifying enough, combine that immense heat with 90 atmospheres of crushing, inescapable pressure just bearing down on you from every possible direction. Now that naturally brings us to a frankly terrifying question, and it's one that's sparked a decades-long obsession for planetary scientists and engineers. How on earth do you engineer a spacecraft to land on a planet that literally eats metal? I mean, how do you build a machine that is sensitive enough to take delicate scientific readings, yet tough enough to survive conditions that would instantly obliterate a modern military submarine? Well, to answer that, we need to look at the challengers who stepped up to the plate. And that means looking at the Soviet space machine and their absolute philosophy of brute force. To really understand how humanity first touched this hellscape, we have to contrast the two distinct engineering philosophies of the Cold War. You had America's pursuit, which was all about technical longevity, building these highly intricate, delicate, and incredibly long-lived spacecraft. But the USSR, their preference was entirely different. They favored mass-produced, heavy-duty resilience. Basically, they built big, they built tough, and they built heavy. And here's the crucial point. This brute force philosophy didn't just appear out of thin air. After World War II, both the US and the Soviets brought in German V-2 rocket scientists. But early Soviet hydrogen bombs were just massive. They were so exceptionally heavy that they essentially forced Soviet engineers to build incredibly powerful, towering rockets, like the R-7, which was the world's first intercontinental ballistic missile. And this heavy lift requirement, it inadvertently handed them a massive advantage in the space race. They possessed the exact sheer lifting capacity needed to just hurl heavily armored, bulky hardware at other planets. But to appreciate what those massive rockets were throwing their hardware into, we need to truly understand our villain. We need to talk about Venus as the ultimate gauntlet. This environment is astonishingly deadly. That 90 atmosphere pressure we mentioned earlier, that is the exact equivalent of being a full kilometer deep in Earth's ocean. Think about that. Any lander has to survive being squeezed relentlessly from all sides by dense, incredibly hot gas. Add to that, skies just completely choked with thick, corrosive sulfuric acid clouds. Oh, in the ground itself, it's filled with treacherous, folded mountain terrains called tessera, featuring these jagged, 60-degree slopes that could easily just topple a lander the second it touches down. And it wasn't just the ground that was actively trying to kill these probes. The atmosphere itself was violently hostile. Scientists actually utilized the Doppler effect, the same phenomenon that makes a police siren change pitch as it speeds past you. They used that to track the shifting radio frequencies of those early descending probes. And what they discovered through these frequency shifts was horrifying. We're talking about 360 km/h winds raging in the atmosphere, violently shoving these heavy spacecraft around like they were cheap plastic toys. Plus, navigating this descent visually is a total nightmare. The thick Venusian air scatters light so intensely that there are literally no shadows. It's exactly like shining a high-powered flashlight straight into a wall of dense fog. The light just bounces everywhere, which means a descending lander gets absolutely zero visual warning of a steep cliff or a massive boulder right beneath it until it's way too late. Undeterred by all of this, the Soviet Union launched the Venera program, and it was nothing short of a relentless, rapid-fire assault. They met this hellish challenge with sheer, stubborn determination, rapidly launching probes throughout the 1960s. They started with total failures, like just trying to leave Earth orbit in 1961. But by 1966, Venera 3 actually became the first human-made object to physically impact another planet. Then, Veneras 4, 5, and 6 managed to transmit data from the atmosphere, though none of them survived down to the surface. But every single failure was crucial. Every crushed, broken probe provided a tiny, vital piece of the puzzle about the hostile world below. They learned the hard way that a hole built for 25 atmospheres is absolutely 100% useless on Venus. The Soviets initially thought Venera 4 had successfully landed, but later data revealed a much darker truth. It was literally crushed like an empty soda can while still high in the atmosphere. It just buckled instantly when it hit the actual 75 to 100 atmospheres of pressure waiting down below. It was a brutal, catastrophic lesson in planetary physics. So by 1970, they completely changed their tactics. They massively overbuilt Venera 7. I mean, they stripped out delicate scientific instruments and just built it like a rigid armored tank. And man, it is a good thing they did. On descent, its parachute ripped and failed completely. The heavy probe plummeted and impacted the rocky ground at a violent 17 meters per second. The chaotic force of that crash caused the entire probe to roll completely over, leaving its primary communication antenna pointing straight down into the alien dirt. But incredibly, it survived. Lying there, battered, totally upside down in an alien hell, Venera 7 miraculously transmitted temperature data back to Earth for an astonishing 23 minutes, right before the insane heat and pressure finally killed its batteries. In that single, fleeting moment, it became the first human-made object to successfully transmit data from the surface of another planet. This monumental achievement kicked off a completely wild era of mind-bending triumphs and, frankly, some deeply frustrating tragedies. To survive longer and actually do some real science down there, the later missions, Venera 9 through 12, scaled up massively. These things were heavyweight, 5-ton behemoths. They utilized completely sealed spherical compartments to protect their fragile electronics, and they featured these massive, donut-shaped, shock-absorbing crush rings to cushion the brutal landings. And guess what? It worked. These phenomenal machines successfully sent back the very first, breathtaking black and white photographs of an alien world's surface. But of course, Venus wasn't done fighting back. The extreme heat and pressure created an agonizing engineering flaw. Imagine the absolute frustration. Your spacecraft survives millions of miles of travel in the dark of space, survives the corrosive acid clouds, survives the 90 atmospheres of pressure, only for the simple mechanical camera lens caps to warp from the heat and get permanently stuck. On multiple missions, these amazing probes landed perfectly, but were totally blind just because a little piece of metal wouldn't pop off the camera lens. And oh, it gets worse. In a twist of dark, tragic irony, Venera 14 actually had a camera lens cap pop off successfully. Great, right? Well, when the probe deployed its mechanical, spring-loaded arm to test the compressibility and hardness of the Venusian soil, the arm swung down and landed squarely on its own discarded lens cap. So after spending millions of dollars in crossing the solar system, Venera 14 flawlessly measured the physical hardness of a piece of Soviet metal. You really can't make this stuff up. Realizing the sheer limitations and the incredible costs of building landers that only survive for an hour or two at best, the Soviets eventually shifted tactics with Venera 15 and 16 in 1983. Instead of landing, they used synthetic aperture radar, or SAR, from orbit. Think of it like a high-tech planetary echolocation. This allowed them to bounce signals right through those dense, opaque clouds and finally map the planet's massive tectonic cracks, ridges, and towering mountains from the safety of space. It fundamentally changed our understanding of Venusian geology forever. So, where does that leave us? After decades of leaving Venus alone, the global space community is finally preparing to return to hell. See, after the Soviet program ended, Venus was largely ignored by landers for decades as the world's attention shifted to the much friendlier surface of Mars. But now we are looking at an exciting new wave of exploration. NASA is targeting the coming decade for its Da Vinci and Veritas missions, which will probe the atmosphere and map the surface in unprecedented detail. India plans to launch its very first Venus orbiter around 2028, and Russia actually aims to carry that legendary Soviet legacy forward with the Venera D mission, proposing a highly capable new orbiter and lander targeting a launch by 2036. But modern engineers face the exact same brutal physics those Soviet pioneers did. Because Venus's atmospheric density changes so incredibly fast during descent, standard retro rockets, like the ones we use to land gently on Mars, would violently misfire and just blow themselves apart. So future landers are probably going to operate much more like deep-sea submarines moving through a fluid. They'll likely use internal fans to navigate the incredibly dense, soup-like air to safely steer down to those jagged tessera mountains. Now, you might be wondering, why are we going through all this trouble again? Well, part of this renewed, intense obsession is driven by the recent detection of chemical signatures like phosphine and ammonia high up in the Venusian atmosphere. Because while the surface is a 465-degree nightmare, the upper clouds are actually surprisingly temperate. And this has sparked the thrilling, highly debated possibility that alien microbial life might actually be floating high above the lethal surface right now. It's a tantalizing thought. Humanity has already proven it can touch the surface of a world that melts lead and crushes steel. So it leaves us with this final, provocative thought. If human ingenuity and sheer brute force perseverance can conquer the most hostile, hellish gauntlet in our entire solar system, what other impossible boundaries in the universe are we ready to break next?